This is the screencast for section 2.1, example 5, using the product rule. All right, so remember back in example 3, I told you that you had to memorize a limit. Do you remember what that was? Do you have that memorized? Because you're going to need it. All right, so first of all, determine the limit as x approaches 0 of the tangent of 0 over, the tangent of x over 0. Well, in the last example, you saw that really all you have to do is plug in 0. Well, let's try that. The tangent of 0 over 0, 0's in the denominator, and the tangent of 0 is 0, so that's undefined. But as you know from pre-calc, 0 over 0 is a good sign. That's a removable discontinuity, because any x value that makes both the numerator and denominator 0 is a removable value. I just got to find out where that y value is, and in essence that means find out what the function's limit is as x approaches 0. Alright, I'm going to look at the tangent of x and the denominator of x a little bit separately at first. So I'm going to take the tangent of x off to the side, and that's going to be multiplied by 1 over x then. Now, tangent is sine over cosine. And since you have that limit memorized from example 3, you can recognize here that you have a sine of x in the numerator and an x in the denominator, and the limit as x approaches 0 of that. So now I'm going to switch the two denominators by properties of multiplying fractions. So now I can separate these two limits using the product rule. And I know from memorizing it that the limit as x approaches 0 of sine of x over x is 1. And I also know from the last section that all I have to do is plug in 0 to find the limit as x approaches 0 of 1 over cosine x. So that's going to be 1 over the cosine of 0. And the cosine of 0 is 1. So I really have 1 times 1. So the limit as x approaches 0 of the tangent of x divided by x is 1. The now try problem number 27 asks me to find the limit as x approaches 0 of the sine squared x over x. From my memorization of that limit as x approaches 0 of sine of x over x, I can kind of see that that's in here. So instead, I'm going to rewrite this as the limit as x approaches 0 of the sine of x over x, and then times my other sine of x, because that was sine squared. Now I can separate the two, the product of these two functions with limits using the product rule. So the limit as x approaches 0 of sine of x over x is 1. And then the limit as x approaches 0 of sine of x is just the sine of 0. Well, the sine of 0 is 0, so this limit is 0. Now number 19 is a little bit different. The limit as x approaches 1 of x minus 1 over x squared minus 1, I should just be able to plug in 1. But I get 0 over 0, and as we talked about before, that is a good sign because that's a removable discontinuity, so I can just remove the problem. This time I won't be using trig values, but this is a difference of squares, so I'm going to break up the difference of squares and simplify, just like we did when we found the y value of the removable discontinuity in pre-calc. The x minus 1's cancel, so now all I'm really finding is the limit as x approaches 1 of 1 over x plus 1. So now I don't need to write the limit after this step because I plug in 1 to find out what that is, and the limit is 1/2.